Good morning, everyone. Hi, I am Ellen Shapiro. I am here from Chicago, where I work for a company called Spot Hero. We would be more than happy to sell you a parking space if you happen to have one of those car things. So if you have a car and you haven't used our app, come find me. I'll show you some cool stuff you can do. I've got a ton to cover and not a ton of time, so I'm going to dive right in. I talk a lot about UI testing since it's something I got into pretty hardcore a few years ago. But for those of you who don't do a lot of testing at all, I wanted to give a really quick two-sentence distinction between UI tests and unit tests. So unit tests generally test very small pieces of independent code, whereas your UI tests are generally something actually poking through the user interface of your application as if it's a user. And I've personally found that no matter what state I inherit a code base in, whether it is beautifully covered in unit tests or it is just this giant mess of spaghetti code with nary a test in sight, UI tests are actually really, really helpful for catching bugs as I write them. Because these UI tests are verifying, does this work for the user? Are the things happening for the user as they're supposed to be, no matter what clean or insane mess work is sitting under the hood? So normally in talks about UI testing by me or anybody else, they're talking about what your options are when you want to write UI tests. You know, should you use KIF, which is short for Keep It Functional, UI testing framework from our fine friends at Square? Should you use the official solution, which is XCUI tests? Those were added by Apple in Xcode 7. Or do you want to be like really cutting edge, and do you want to go for EarlGrey, which is this brand new iOS UI testing framework from Google that's very similar to the Espresso testing that they use for Android? And after all of that lead up, normally these talks get to a question of what framework the presenter thinks that you should use. But I am actually going to defer to a wiser woman than I, Judge Judy, and say, who cares? I don't care. Like Judge Judy, I actually don't care. Each of these approaches has its advantages and disadvantages. What I actually want to talk about today is something else. This is a single technique. And you can use this technique with any of the testing frameworks that I just mentioned, or if you are crazy like I am, you can actually use it with all of them at once. And this technique is called robots, the robot pattern. I really, really, really like this pattern, not just because it has a super awesome name, but because it makes the intentions of your tests much clearer. It makes test cases easier to read, and it makes your whole testing strategy more behavior-driven. And you don't need any kind of framework for this. One of the things that drives me absolutely bonkers about most behavior-driven testing is that you either have to bring in some sort of weird Ruby-inspired BDD framework like Kiwi, which that just makes me want to scream, or you wind up putting a ton of information in your comments, which don't break as obviously when you make changes as functions or methods do. But with robots, you don't have to have either of these problems. So I first heard about this technique from a great video on Realm's website of a talk at the Kotlin Android user group here in San Francisco by Jake Wharton, who's basically Mr. Android. If you guys remember Matt with 3Ts Thompson's sort of dominance of the iOS open source landscape with NS Hipster and AF Networking and an Alamo Fire a few years ago, Jake Wharton is basically that, except he works for Square instead of Google, so he's still pushing out tons and tons of new libraries. Now, since this talk was at a Kotlin user group, and Kotlin is a JVM-compatible language that's used a lot in Android applications, Jake was talking quite a bit about sort of very Kotlin-specific ways of implementing this pattern. But what really grabbed me about this talk was the way that he showed off the technique and how it could be used in any language and any testing scenario. One of the biggest things that he talked about was that when you have test code, it's often really hard to grasp when you first get a hold of it. You know, take this stuff, for example. What the hell is this doing? What on earth is a tester? Why are there all of these weights? Why are we dealing with so many accessibility labels? And most importantly, why the hell do I care? So here I'm going to pause to note that most of the screenshots you're going to see today and an example implementation of the robot pattern are coming from the sample app that I've been using for iOS UI testing since late 2015, when I rather enthusiastically jumped on the bandwagon for the Chicago Cubs. And, that's been a little bit of an emotional roller coaster, but it's been a really fun thing to have for testing examples, because you can see how different code can be as you go through and test it, even when the app itself is pretty simple. In this case, it's just got two main screens, a list of all the games that the Cubs played in a given year, and then a detail screen, which allows you to see more information about the result. And, I initially built off the app in 2015 to show off the differences between UI testing using XCUI and KIF. And you already saw how bad the KIF code was. The XCUI code really wasn't a whole hell of a lot better. And since I'd written a bunch of tests that were doing similar things, like any sane programmer, I wrote some convenience methods to avoid repeating myself. And that helped a little bit, but it still left a lot of implementation details exposed in my code. I still had to have totally different implementations to test exactly the same thing in XCUI and KIF, which is really annoying, especially when I decided I wanted to take a stab at adding EarlGrey into the mix. And so I went back to update the project with the results of the 2016 Cubs season, which, as you might have heard, were pretty damn good. And I decided to give the robot pattern a try. And like the Cubs winning the World Series, it was really awesome. I've now got KIF, XCUI, and EarlGrey tests all calling into the same method. There is no information in this method about how it's going to go about verifying whatever it's trying to verify. And there's no direct information about the test mechanisms at work. You only know what is being tested, you don't know how. And that's a key concept of the robot pattern, that you separate the what from the how. So for example, you may look at this awesome beer dispensing robot that the Metropolitan Brewing Company in Chicago built and go, holy crap, that's amazing. And spoiler alert, this works because there's tubing that runs from two pony kegs in the leg through a jockey box full of ice in the body and then out the arms, each of which has a tap on it. But what if you wanted to test this contraption? What if your primary concern was not how does this work, but does this do what I expect it to? If you pull the tap on one of the hands, A, does beer come out? B, is it the beer that you were expecting to come out of that hand? C, is it actually cold? And for something as simple as this, you could easily break those separate tests into one single suite. But when you start working with larger code bases or more complicated beer dispensing contraptions, you start to see bigger benefits from breaking things up into these little robots because you get more composable test code. You wind up with a system that basically gives you a bunch of little Lego bits which you can build into anything you want without having to rewrite all of your test code. Now, one thing you may have noticed on the updated test that I showed you earlier was that I was using a list robot and a detail robot. The list robot does things related to the list, the detail robot does things related to the detail screen. Pretty obvious separation of concerns, but not terribly exciting. Since right now these are the only two screens in the application, it's really all I needed. But what happens when you start to apply this to a more complicated application? Well, and Spot Hero, our Android tests have started to adopt this pattern, and the developer who's been spearheading this, whose name is David Ryan, built out a bunch of robots that actually make it really easy to reuse this kind of test code across multiple tests. So for instance, we have this menu with a bunch of options in it, and he built what he dubbed the hamburger robot in honor of the little hamburger button that sits there and opens and closes the menu. And it's making sure that everything is on the menu page, which is supposed to be, and then it opens and closes the menu, and then it selects items from the menu, and that's all it does. But now he's able to reuse that same robot across multiple different tests, and he's able to do that as he writes tests for each section and goes into each section. He can use this wherever he wants because there's no messy inheritance chain. He doesn't have to worry about what the superclass is. Now, if any of you guys have worked in automated QA before, I'm pretty sure you've been thinking, wait a minute, this sounds really familiar. I've been doing this since I was breaking flip phones. When I write tests that run on different browsers or operating system or devices all in one place but have different underlying implementation, I call that controllers. And in fact, when I showed Jake Wharton's talk to our Eduardo Reynoso, who's our automated QA guy at Spot Hero, his immediate reaction was, oh, so you mean controllers. So I will clarify that the robot pattern is also known as the controller pattern in a lot of places. I still prefer calling these things robot because A, it sounds cooler, and B, I can mentally picture a little robot in its little robot voice saying, I tap this button, I check that the text of this view says Cubs. And then it makes it easier for me to figure out how to break things up because I can imagine these little robots passing the UI down sort of an assembly line. You, however, can call these things whatever you want in your code. But speaking of code, since this is a Swift conference, the question of how do we adapt this idea for Swift comes to the forefront. Now, as with many things in Swift over the last year and a half, the answer, of course, is protocols. So if you're here, you've most likely watched the WWDC videos featuring everybody's favorite cranky old programmer, Krusty, which were introduced by Dave Abrams. He's the tech lead for the Swift Standard Library. And he taught everybody how he learned from Krusty about protocol-oriented programming. And Dave and Krusty mostly demonstrated how useful this is in an application. I think that the robot pattern is a really good example of how well it can work when you're testing. So going back to the Cubs game app, I declared a super basic robot protocol. You'll see that all the methods here are named to describe what they are going to do, not how they're going to do it. And by the way, if you're wondering why I'm passing file and line around all over the place here, Joe Mazzolotti has a really great post I'll link in the slides about using XC test helpers to actually have a failure show at the point of the test that's failing rather than at the point in the helper where it's failing. Anyway, now that I have this protocol declared, I can start creating all of the concrete implementations in it. So I've got my KIF implementation, which uses the KIF tester to make sure that something is visible. I've got my XCUI implementation, which uses the XCUI application and the XC test expectation methods to ensure the appropriate view is visible. And then I've got an EarlGrey implementation, which uses this really Java-y DSL and matchers to step through the view once animations have completed. So that is a very standard use of protocols with different implementations. Where things get really fun is when you start to use other protocols which conform to this protocol and has a default implementation. So here is the detail robot. The game detail robot also conforms to the basic robot protocol, which means that it can use any of the methods in the game detail or in the basic robot protocol. You can use a default implementation of the detail robot to describe exactly how, from a logical standpoint, you want to verify that the screen is currently visible, that screen is the detail screen. And as a bonus, since there aren't any functions in this protocol which don't have a default implementation in the protocol extension, you don't actually have to declare that those functions need to be conformed to. So you just have an empty protocol declaration and a whole bunch of functions. For the KIF and XCUI robots, all you have to do is add an annotation that it conforms to the game detail robot protocol. You are totally done. The default implementations of functions in the protocol take care of everything else. The EarlGrey robot was a little bit more complicated. So most tests and the accessibility inspector were able to see this little button with its accessibility label of back. For the life of me, I could not figure out how to get EarlGrey to see the actual back button. I eventually realized I could get it to go back by using the actual title of the back button. So this exposes a pretty solid gotcha, which is protocol specific. And, oh gosh. If you have a default implementation of a given method in your protocol extension, but you want to use a different implementation of something which only has the protocol as a property, you actually have to cast the instance of the implementing class or struct, or the protocol will try to use the default implementation. Since the property is of the type of the protocol, it doesn't actually know anything about any of the other implementations. It only knows about the default implementation. You have to specifically tell it, hey, use this specific implementation in order for it to know that there even is a different implementation to use. There's also some gotchas with multiple variations, and I found this really, really interesting to use and build and test, but there are some crazy things that can happen when you're trying to test multiple things. My original vision for this technique was that I would have each set of tests sitting in its own folder, those bottom three folders, and then each of those three folders corresponds with a different testing target. And then that shared UI test files would have files that were shared across all three targets. And ideally, it was going to be the robots, a couple of helper classes, and then this parent set of tests, the robot tests. Now, in an ideal world, the robot tests could be extended by all three subclasses, allowing the test methods to all the test classes would eventually have to do that you're writing for each of those three packages. Ideally, you would be able to just say, okay, here's your setup method, here's your teardown method, and then the superclass could take care of actually running all of the tests. So the best laid plans are always laid to waste by subtle differences in how each of the frameworks implements UI testing. In this case, XCUI test and EarlGrey test both subclass XC test case directly. KIF uses an indirect subclass to set up everything that it needs to actually perform the tests. So all three of these tests could not extend the same superclass. Fortunately, since KIF test case extends XC test case, I could consolidate the test code by using, you guessed it, MOAR protocols. I'm pretty sure Krusty would be very proud of this solution. So instead of having the robot test extend XC test case and having the list robot and detail robot be properties of the robot test class directly, I made them required properties for the robot test protocol and then added a default extension where self equals XC test case. So I could still have all of the stuff that I needed to perform assertions and do all that kind of logic in the methods that I had. And then I went on my merry little way, creating all these little methods which could be called from any direct or indirect subclass of XC test case. And then I was able to make all of my test classes conform to this protocol, allowing these really simple tests. Now, there is one thing that slightly sucks about this. If you have an XC test case which conforms to a protocol that's with a method that starts with test, so I initially tried to name all of these things, test, blah, 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 except when you actually run this, the test sidebar sees all of these. The test runner itself does not. The tests will pass having run exactly 0 of these methods. So you have to actually declare the actual test blah, blah, blah function in an actual subclass of XC test case. So I worked around this by basically having a single method that each of these tests corresponded to, and then having all of the actual test methods be the same across all 3 test cases. This is the only piece of copy pasta that's happening in the app. If you leave KIF or any other testing option which requires an indirect subclass of XC test case out, the good news is that this you don't have to worry about. There is one other thing you might have to worry about, which is using testable import. Testable importing is a great way to be able to import classes, functions, and properties which are normally internal to a given module without having to make all their properties public. In my case, I normally use it to bring in accessibility, methods that I use to make sure that I'm constantly using the same accessibility label or localized string across both my tests and my application. And it works really great in anything that is running in the same process as the main application. However, XCUI tests run in a totally separate process from your main application. And what's really goofy about how this works is that instead of throwing some kind of warning when you try to testable import something into a set of XC test case or XCUI tests, it just no-ops. It just sits there and does literally nothing. You wind up with a bunch of errors that you can't necessarily understand unless you understand how this works under the hood. However, we can actually take this weird behavior and turn it to our advantage when using testable import with robots. You can add a little note here for people who haven't been to this talk and say, hey, if you're doing XCUI tests, you have to actually add the file to the XCUI target. Our friendly little target membership thing, you don't have to add the file to the Go Cubs KIF test or the Go Cubs EarlGrey test because those both can use testable import and they don't have to have access to the file directly. The Go Cubs XCUI tests has to have access to that file directly. And it's really awesome because when you're doing this, you're able to, by simply checking a box, still use the same exact files with no changes whatsoever across your XCUI, your KIF, or your EarlGrey tests. That is a very, very, very high-level overview. Some of it got a little bit into the weeds. I know that I'm basically running up on time, so I'm going to go to the obligatory summary slide. Everybody loves a good summary slide, right? So why do you want to use robots? You want to make sure that your UI tests are really clear about what you're trying to accomplish, and that it's easy, and that is much easier to do when you abstract what you're doing from how you're doing it. It's really helpful for keeping your tests readable, but it's also really helpful that new developers coming into your application and even non-developers like QA engineers or manual testers, even product owners can come in and look at what you've written and have a decent idea of what you're trying to do. It also lets you swap out the underlying implementation of your test code, making it much easier to try out new UI testing tools and poking at their advantages and disadvantages. It also can come in super handy when, say, Apple breaks the living crap out of XCUI testing on the simulator in Xcode 8.2 and does not fix it until Xcode 8.3, allegedly. So that's something where if you actually pull the sample code from today and try to run it on Xcode 8.2, all of the KIF tests will pass, all of the EarlGrey tests will pass. If you run the XCUI tests on a device, they will pass. If you run them on the simulator, it will often time out because of a bug in how accessibility snapshotting is working on the simulator. So that's fun. And finally, naming things is never simple, but a good piece of free advice is that giving techniques cool names makes it a lot more likely that people are actually going to use them. So I've got a bunch of links. I'm going to be posting these slides on SpeakerDeck. I'll tweet out a link, and I'll try to make sure that there's someplace where people who hate Twitter can also access it. And that's really about it. I would love to hear any questions you guys have. I've been really enjoying working with this, and it's something that I'm really excited to bring into the Spot Hero app. Thanks, everybody.